Is everyone ready? Raise your hand if you're still working on this part. Okay. Okay, now that everyone's in Jupyter, does anyone remember what you're gonna want to import in order to be able to plot things? It's kind of a long, so okay, I'll just let you. It's import mat.
Do you want to make it a little bigger? Just to
Control.
yeah.
Can everyone see? Okay. We're just gonna do import matplotlib.pyplot as PLT. And then I'm also gonna import NumPy because we're gonna be using it as well. And then I'm gonna run that. So obviously in order to plot things, you're gonna need X data and Y data. So let's say I just want to plot a sine wave with my X from 0 to 100. Does anyone know any NumPy functions that you could use to get your X data, to get an array from 0 to 100? Does anyone remember that? mp.arrange, and that's going to create an array from your start, which we just want it to be 0, to your end, which is going to be 100. And by default, it's going to have a step of 1 if we don't specify. And then our y, we can just use NumPy to create a sine wave, and we want it to be for every x. So we're going to do np.sine x, then run that. Now, in order to actually plot our figure, what's the first thing you're going to want to write? Like the top piece of bread in your figure sandwich.
PLT.show. Dot plot.
There's one before that. That's going to like make the canvas for your plot. Do you remember what it is? Yeah. And then after that, we'll do the plt.plot. And then when you do plt.plot, you're going to want to do your x data and your y data. We just called those x and y, so we can just write x, y. And I'm going to label my plot based on the amplitude of the sine wave. So I'm just going to write label is equal to 1. And then you can plot several lines in the same figure. So if I want to plot another sine wave in the same figure with an amplitude of 0.5, I can do x y times 0.5. And then I'll label this one 0.5. Is everyone following? Does anyone have any questions? We'll give a little bit of time for everyone to get to this point. Okay, so once you have this, in order for people to know what they're looking at when they look at your figure, what do you guys think we should add? Yeah. So for our X label, we'll just call that X. You can call it whatever you want. And then for our Y label, we can just call that Y. And then we can also add another thing to make it more clear what we're looking at. We can add a title, and we can just call that sine. Okay, then what's the last thing that we need to write for a figure to actually show? I think someone mentioned it earlier, it's just plt.show. Okay, now let's run that. And as you can see, it creates a nice little figure. But there is an orange line and a blue line, and it's kind of unclear which is which. So does anyone remember what we need to write for it to actually tell us which one is our 0.5 amplitude sine wave and which one is the 1 amplitude one? Exactly. So once we do that, it should create a legend that's going to tell us which is which. And as you can see, it's in the corner right over there, and it specifies which color line is which so that you know what you're looking at. And it's kind of like pointy because we didn't specify the step, and the step is kind of big right now. But if you wanted to, you could go into your arrange and make it a step of 0.1. And then once you do that, it'll make it like a nicer looking sine wave. But yeah. Okay.
Okay, how do we feel about all this? Did we get it done? Question?
This is module of
Okay, thumbs up, thumbs down. Thumbs up, it looks like this. Thumbs down, it does not look like this. Okay, looks good. Let's move on. So those are the basics for making like the most generic plot you can in Python, which is super helpful, and you're gonna need to use it all the time probably. But sometimes just plotting like a line plot with like the basic default colors is really not good enough for your uses. So let me close these windows. So here's some other things that you can do with matplotlib.pyplot. If you're wondering why it's called that, it's because matplotlib is the plotting library used in MATLAB. So this is like the Python wrapper for it. So these plots will look very similar to the ones you see in MATLAB, and that's on purpose. But this is the line plot that we did before, just plt.plot. We make scatter plots using plt.scatter, so nicely named. And then there's also bar graphs. There's like histograms too. So if you need to make a specific kind of plot, they probably have it. They have all kinds of stuff, but here's some examples. And then here's like how you customize your plot. So before we had like the generic blue and orange lines, kind of nothing to be done about that, except that there is something to be done about that. You can change the color of the line. There's a color argument. You can skip it if you're lazy. Usually it's better to just be explicit and say color equals. In this case, we use red. There's like a trillion different colors and you're going to see them in a second. You can change the thickness of the line, so you can make them super thick or super thin or anything in the middle. And you can change the marker type too. So if you have a bunch of different lines in the same plot, you can go ahead and change this and it'll make the little dots look different on a scatter plot, or on a line plot, they'll also look different. And then alpha is used all over Python to mean opacity. So not just in matplotlib, but in all kinds of other libraries. Alpha means opacity, and so you can change that on any kind of pyplot graph to change the opacity of your figure. And that's also super helpful for if you have multiple lines on the same figure. So let's see. If you want to change the size of your plot, so like when we did it just now, it was like kind of small. If you want to make it bigger or like even smaller for some reason, when you do the plt.figure, we called it with no arguments, just blank parentheses. You can put a fig size in there with a tuple that has the size. So this is, I think this is width times height. I might be wrong. This is the size of like your canvas. And then you can add error bars as well. This is like a specific function you use, and you give it a column that has your y errors, and it will add the little error bars directly on the points. So that can also be really helpful for especially like scientific diagrams. Okay, let's do it then. So go back to your Jupyter notebook if you never left, stay there. And we'll do this really quick. Okay. Someone tell me what the first thing I do is to make a new plot. From the audience. Someone help me, I'm like hung out to dry.
plt.figure.
Yes, thank you. And then I don't care about the size because I'm boring, but you can change the size if you want. So why don't I'm gonna plot whatever I want. So, because I don't have to, I can do whatever, it's a free country. I can plot whatever I want. So let's see, I want to make an X array that is from 0 to 10 with 100 points. No, actually, let's do 10 points. So you can use an A range for this too. But since I'm like making this up as we go, I'm using a linspace. So you don't have to do it just like this, but I'm doing it like this. Okay, does anyone have like a favorite math function? Do you have a question? Okay, I need to plot a kind of math function. We did the sine last time. Does anyone have any ideas for like a different math function I could use? Like anything? Square, polynomial, exponential? What were you gonna say?
Logarithm.
Log. Any other? Okay, I could do that. I could also Okay, let's do something. We're gonna take pity on me and we're gonna do something easy. So we're gonna do, let's do log. Sorry, I know I called your function boring. I'm sorry. More boring than Lagrangian polynomials. So we're gonna make my y's. I only have 10 points. We're gonna see y in a second. Okay, so I have my figure, and then someone remind me how I make a scatter plot. I showed you it really quickly. If you don't remember, it's okay.
PLT dot scatter.
Yes. Okay, what's the first thing I put in here? I can't just call this. You can use like vibes. Yeah.
Yeah, X.
Yeah, X. Yeah. And then what's the last thing that I need to finish my sandwich? Yes. Okay, so let's go ahead and run this. I didn't think ahead and use a log and I included a 0, so that's my bad. But it's not the end of the world. Yippee! Okay, I have a plot. And it looks like a log and only has, I think this has 9 points because of that stupid 0.
Oh, wait. Oh,
Did we all get this? Problems? Anything weird happen? What happened?
I got a giant.
Okay, let's see.
Line space doesn't have a gate in it.
It does not.
It's just lives there.
So yeah, so you're the same 0. Let me just fix that for everybody. Okay, if you're having the divide by 0 issues and it's not letting you continue, just change this to a 1. Because it's a log, and then that should fix it. Yeah, so go ahead and just change that 0 to a 1 so we don't have the 0 thing.
Why does it work for me? I have 0, but still.
Yeah, so you have a 0 and it's ignoring that point. Some people are in here. And then we'll try to- Okay, here's what's going on.
It just last let's say.
Yeah, see-
In terms of the chemical potentials. Or there.
Oh, okay.
The
dimensions on my.
One second.
I feel
Yeah, yeah.
Oh, you need to fix it. You need another second.
Because I couldn't figure out how to make
That's
that.
Yeah.
Any other questions? Yeah, what's your- Okay, we made our awesome log plot that starts at 1 and not 0. Unless yours works for 0, in which case you're cool and awesome. But this is so boring, like guys. Like these are just like blue points. And I'm looking at it and I'm like, I'm yawning, you know? We should do something more fun. And I just showed you guys all that stuff about colors and other crap. So we should go do that. So what I want you guys to do is to open a browser tab. Let me do that. I will show you. So open a browser tab and type in matplotlib colors. Spell matplotlib correctly, I didn't. And then click on this first link. And then look at all the colors. And then I'm going to ask you for your favorite color in here. But yeah, just put in matplotlib colors and then click on the first link. And then get overwhelmed by all of the colors. And then we're going to pick one as a group. You'll have to scroll down. It should look like this horrible thing. Okay.
Oh. Yeah. Oh, blue lines. What? Blue lines. Oh, wait, Rebecca. Yeah. Rebecca. Where are these named for? Dark. Dark. Cold. It's like, very long.
Okay, we've had some time to look at all of the wonderful colors. I want to pick, let's just pick one for now. but I want to hear what you guys found because there's a lot of them and I haven't seen all of them. So does anyone have like a nice looking one or just like a weird one? Yeah,
Cornflower blue.
cornflower blue. Anything else? Yeah,
Thanks.
hot pink. That's a good one. Anything else? Yeah, Rebecca purple. That's a classic. Okay, should we go between these three or does anyone have any other nominations for good colors?
Crimson.
Crimson? All right, so we have cornflower blue, hot pink, Rebecca purple, and crimson. So we're gonna vote actually because, okay. And then, what was the last one? Oh, crimson. How do I do a vote between four things? Okay, let's vote between the first two. Okay, we're gonna do a bracket. Okay. Give me a thumbs up if you want cornflower blue or thumbs down for hot pink. Okay, you can't do both. Okay, I hate to say, but cornflower blue is winning. So let's pick between Rebecca purple and crimson now. Thumbs up for purple, thumbs down for crimson. This isn't like a value judgment, but just picking between. All right, you guys cancel each other out. Okay, we got Rebecca purple winning. Okay, so let's pick between cornflower blue and Rebecca purple. The final two winners. Thumbs up for blue, thumbs down for purple. Go. Down for purple, up for blue. Weird number thumbs up all of a sudden. Okay, actually purple won. So we're gonna do purple. But this is how you add that in. So X comma Y and then color equals. So very straightforward. And then in quotes, because it's a name, we're gonna put Rebecca purple. I don't know how to spell this, hold on. It's gotta be over here somewhere. Do I need to search for it? Where, no, did I miss it? Oh, there it is, okay. No spaces, just Rebecca purple. All right. Nice. Oh my God, guys, it's purple. That was worth all the effort, I think, because now it's just not blue anymore. So that's a nice color, so whoever picked that, thank you. That's a good nomination. Okay, so let's change the fig size really quick because this is like kind of tricky if you've never done it before. So you go to the figure argument and then we're gonna type fig size and like inside the parentheses, the equal sign. This is called a named argument, which means you have to put the name of the argument's fig size and then the equal sign. And then you have to pass in size as a tuple of values, which is each dimension. And so we're gonna give it, someone name a number between 1 and 10. It doesn't have to be an integer.
Pi. Pi.
Pi. I don't think this will work, guys. Okay, we'll see. It works. Okay, give me another number.
3.1. You just put it in there. You just round it.
All right, fine. We can't do exactly pi, but I need to assert that I'm cooler than you, so I put in more digits. Give me another digit between 0 and 5. 3. E, guys. How about okay, how about 2 then? That's like kind of close. 2.7.
Yeah, there's like the page. And that's that.
All right, well, this is.
Yeah, look up right now.
I just, guys, I was hoping to make it bigger, and then we as a collective made it like half the size. So good job. But that's what it looks like. I'm gonna make these whole numbers so it looks a little bit clearer. But you can do decimals. Yeah, that's so small, guys. Okay. I'm gonna make it bigger because I want it to be really big. So we made it bigger. The other important, okay, there's 3 more important things I want to go over for this part, which is line style stuff and marker. So let's change the line width really quick. You go back into the plot argument. We're going to put it after color. As long as it goes after X and Y, it's fine. It doesn't matter where it goes. Called line width. No spaces, nothing fancy, just line width. And then someone give me a number between 0 and 20. Please make it an integer this time. I can't do E anymore. 17. Wait, this isn't gonna work. This is a scatter. We're also gonna change the scatter to plot because I'm dumb. So go ahead and fix that. Of course, it's line width, so we need to do a line plot. Change that to plot, and then we pretend like it's fine.
Make the circle bigger or something.
No, make the line really chunky. 71.
No.
All right.
I don't think it works.
All right. What do we think of our handiwork? That was really good. Let me make this a little smaller again. Okay, so this is at the line with the 71, if you wanted that for reference. Usually you want to do stuff between like 0 and 20, but 71 is fine. Okay, so now that we have our incredibly thick line, very chunky line, we're gonna change the style. So sometimes when you look at plots, there's like dashed lines, dotted lines, whatever. It's called line style. And the line style argument can either be like really, really, really complicated or very simple. You can like specify your own custom pattern if you want in line style, but there's also a lot of default ones. So there's like dot, there's dashed, whatever. Dash dot is like fun. It's not, but I think it's fun. So if you put that in, we can see what that does. It makes a dash dot pattern on the line. And again, the line with the 71, so it's kind of hard to see. Put this back to 17. Okay, that looks a little better. So changes the line style so you can dash it, dot it, whatever. And then let's do one more thing with markers and then we're gonna move on because this is taking a long time. So go ahead and just copy that to the next line. Change the plot back to scatter. Or put that back. What it was before, back to scatter. And then delete these two. Oh, this is like plot specific stuff. So anything with a line in it, bye-bye, adios, delete it. And then we're gonna change the marker. So just put in the word marker equals, and then we're gonna do another fun experiment, which is you're gonna go open up another browser tab and put in matplotlib markers. And then you're gonna click on the very first link again. And then you're gonna look at all the markers that they have because they have a lot. So just start scrolling through the list until you find one that you like, and then we're gonna share, and it's gonna be fun. So this is how you get there. And then I'll give you like 52 seconds to come up with your favorite marker, so start thinking. Okay, it's been 52 seconds. We're gonna move on. Okay. I need a marker. Did anyone find a cool one? There's a lot. Hexagon, try which one? Star. Ooh, okay. Any other ones? Yeah. This one? You want to render the points using math text? Okay. Sure, that's cool. Did anyone beat string or star or try? A lot of good ones. Okay, so we're gonna use, what do I want to use? Should we use this? Should we use the math text one, guys? We're gonna use the math text one. I've like never used this one before, so this is gonna be really interesting. Oh my god, there's F's. It worked. I'm gonna give myself some more points. Yeah, there we go. Yeah, we got F's. Nice. I don't know what this like tells me at all, but there's F's now. So I think that's worth the effort, you know? But my F's are like kind of small right now, so that's sad. I want to be able to see the F's more clearly, so I'm gonna make them size 20. Okay, I can't do that. Is it just S? It might be just S. Did I make them even smaller? Where did they go? Okay, they're bigger. I don't know, that was so hard for no reason. But yeah, make your custom marker. You don't have to use the F string if you don't want to. And then change the size. Size is important. Big Fs. I forgot that they look so small because the line is so thick. But yeah, big markers, custom marker, custom color. I think that's all we need. Someone tell me how to add a title. What do I do?
PLT.title.
Yes. What do we want to call it? Yeah. There we go. Yeah, there we go. I think this is the best plot I've ever made in my life. Very informative, helpful, clear, communicative. A little thin. Yeah. Okay. So this is like basics of customizing your plot. Does anyone have like any actual questions about this? Yeah?
Getting adding.
Make that the more you're giving, that way to change that, like, give them. Yeah, sounds about right.
Any other questions? Anything like not work? Thumbs up, thumbs down. Okay, thumbs up, you want to move the heck on. Thumbs down, you want to do this more for some reason. You want to do more. Okay.
Wait,
Yeah.
how did you like increase the density of Fs?
Oh, I cheated and I went back up to the lid space and I made it 50 instead of 10. Because I wanted more Fs in my life. Hopefully, I hope my transcript doesn't hear that I said that.
That's what I was just thinking.
All right, so we're gonna move on. I know some people want to keep doing this, but I do actually need to like teach you more things, such as subplots. I want it to be known that I didn't put these, someone else did, but they're there and we have to contend with that fact now. So you might be thinking, okay, I can make one plot, but whenever you read papers and like articles and whatnot, there's always like a bunch of them, and they're almost always like very close to each other, or they're sharing like an axis or something, or like they have similar color scheme, something like that. They're like related to each other. So how do we do that? It turns out you can totally do that, and it also turns out that this is my least favorite part of matplotlib, the entire thing. I hate them, but we're gonna go over it anyways. Is this the end of the slides? Oh, I said this already. Okay, there's a lot of different ways to do subplots, as in putting multiple separate plots onto one canvas. So what we did before was putting multiple lines onto the same canvas. So we had the scatter plot and the line plot in the same like X and Y axis. We don't want to do that this time. We want to have them separately like we saw before, the 2x2. So there's a lot of variations on this. So if you forget how to do it and you look up like matplotlib subplot, you will find like 10 different ways of doing it, and they're all terrible. But this is one of them. I think this one's like okay. Like if you're gonna use any of them, maybe try to use this one. But again, they're all bad, and you will have problems with every single one. So if you're not looking forward to doing subplots now, I don't know what's gonna get you worse. Let's just move on. Let's just do a demo. Again, I didn't put that, someone else did. But go back to your demo notebook and then let's just crank this out. Let me out. Let me out. Okay. Okay, I'm gonna like put that away. All right. So for subplots, the whole figure sandwich, except the very bottom, is slightly different. So I'm just going to tell you how to do the first line. So instead of doing plt.figure, we're going to do something like slightly different. Because we want to put multiple separate figures on one figure, it's kind of like you make a figure and then you put a bunch of stuff on that figure, but then each of those things is its own figure. I hope that helped. But basically, we want to be able to create a figure that we can reference later and then like stick stuff on it. So the way we do that is we say plt.subplots. And then inside these parentheses is, let me make it a little bigger. Inside here is where you're going to put the size of your subplots. And by that, I mean like the number you want for rows and then the number you want for columns. So you can think of it as like initializing kind of a matrix. So I want to make 2 by 2. You can do whatever you want, but 2 by 2 is like she's like Old Faithful, you know, kind of hard to go wrong with the 2 by 2. So this will give us 2 rows, 2 columns, so 4 total. And then I need to be able, so once I create all of my canvases, I need to be able to refer to them later so that I can put my lines on them. So the way we do that is we first give ourselves like the whole canvas to refer to. We're gonna call it fig because that's convention, and then AXS. So go ahead and just type that. So there's 2 parts to this. Fig is like the whole thing. So like you have the 2 by 2 and they're stuck onto a bigger thing, and that's the fig. And then AXS, that's gonna be like each individual smaller plot. So for the previous example, that was like 1, 2, 3, 4. AXS contains a reference to each one of those in one object. So when you look at this up yourself, you're going to see like basically a lot of different variations on writing this line. But I think this is the simplest one, so we're just going to stick with it. So we have that. And then how do I actually put stuff on it? I only have 2 things to refer to, but I have 4 plots. This is how you do it. So I said the AXS has a reference to like all 4 of those plots. So how do I get those? It's kind of like indexing a list like you guys have done before in like the NumPy arrays. So open your square brackets, which I'm sure you guys have like a little bit of trauma doing by now. But we get to do it again because you never get to get away from square bracket indexing. Okay, so we can imagine that we have a 2 by 2 list, like a 2-dimensional list, like a matrix. I want to get the first row and the first column of that matrix. From like NumPy list indexing, does anyone remember what I would want to put in here to get that specific location? Like the very top left corner.
0.
0. I need one more number. It's first row, first column, so it's 2 dimensions.
0 again.
Yeah, 0, 0. Great. So this is how we're going to get the very first row and the very first column. So that top left one. And then from here, we can pretend like everything's the same as it was before. So I want to plot something. So just use the same command. And I remember someone brought up that like if you rename X and Y, that can like do really weird stuff later on. So we're going to do that. We're going to put in X and Y. And I like don't remember what these are. But we're going to find out. And it's going to be, I think it's the exponential thing from before. But I don't want to define them again. So just put those in there. And then we can also set the color in here, like everything is the same. And then if you want to look at one of the other plots, we can get like, if I want to do the first row and then the second column, how would I index that? What's the first number? First thing I want to put in the square brackets.
0.
0. What's the second one?
1.
1, exactly. So let me change that to make it more consistent. We're going to plot something else. what do I want to plot? Let's just divide it by 2. And then for the rest of these, it's going to be really similar. So I want the second row, the first column. So this is going to be a 1 and a 0. And then second row, second column will be 1, 1. And we're just going to leave this. And then, of course, so the last thing we need to do for the figure sandwich is going to be the show. So let's do that. And then we're going to run this and hope it works. Okay, there we go. So I did do it right. So we have 4 plots. Okay, I'm gonna go back to the code if you guys need to copy it. But we have, these are cut off, but we have 4 plots on one bigger canvas, which is the fig, and they all have the different things on them that you can put. So this one's red. And then these are all half magnitude. And you can like put all the customized gradients in all of these like you normally would. Only the beginning is different, and that tells you where to put that line. And you can put multiple lines on one of these too. Totally fine. Any questions about this? Yeah.
Is AXS a variable? Like, can we make multiple of these under different variables?
You mean like AXS is a variable. What do you mean by make multiple?
Like, we make one plot under AXS and then another plot and have them referenced separately.
I mean, if you wanted to make another like subplot instance, like we could like copy all of this, and then I could like put it in here, and then we could do it again, and that'll be fine. I don't think that's what you're asking.
I'm thinking the second time we do it, we'll be referencing to our first bundle of plots.
Or like if I run these, will I get like different things?
Like, supposing we want to plot something different on our next batch,
Mhm.
we'll be referencing our first batch because we're still saying, we're still referencing AXS. If that makes any sense.
So when I define the fig ax line, I see like AXS equals plt.subplots. And when I do that, I make like a fully fresh new subplot thing. So when I run all the lines after that use AXS, it's like all of these are only referencing this one. So when I do it later, like in this one, I redefine AXS as this one. So they're like fresh. It's kind of the same way as like we just called X and Y and I didn't say what they were, but they're all like this log graph, even though way long ago, we defined it as a sign. That's because later I explicitly said it's a linspace and a log. So I redefined them, and then we use whatever the most recent value was. Did that help? Any other questions about subplots or anything? They're like kind of confusing. Okay, thumbs up, like we're good. Okay, looks like we're doing pretty good. That is actually everything we have for today. So we kind of like blasted through that. If you guys need to reference the slides, which you probably will for the homework coming up, I'll put them somewhere, Canvas. I'll link them. But yeah, that's all we have. So feel free to ask questions or question. Oh yeah, so these are like auto labeled. But if you wanted to do like I think in the slides there's like a little example where these are like sort of shared between plots, like these are one, and these don't have the labels because they're shared. That's just like a special little argument that you add in. It's called, I don't remember what it is. Share Y. Okay, so you use like share Y or something, and then that would like enable this behavior. If you wanted to force all of them to be the same, that's probably the way to do it. Or you can manually set the X limits and Y limits of each plot. The same way we did the dot plot. So say like AXS dot like set Y lim, and you can force it manually. Okay, what was I saying? Not what I was trying to do. If you have any other questions, feel free to stick behind and ask. Otherwise, content is done, so feel free to head out. And thanks for showing up. I know it's pretty late in the semester, but we have a lot of people, so we appreciate you guys. And have a good one.